theorem in SRSWOR is variance of sample mean. That is variance of y bar n is equal to n minus n by s square into n. You need to prove this. This is nothing but variance of sample mean under SRSWOR. So before proving this, I think you know the definition for variance in terms of expectation. V of x square minus p of x whole square. By using this result, we can write variance of y bar n is equal to expectation of y bar n square minus expectation of y bar n whole square. Okay, we know that in the theorem 2, using theorem 2, we know that in SRSWOR, sample mean is unbiased estimator of population mean. So, what does it mean? Statement E of y bar n is equal to capital Y bar n. So, variance of y bar n is equal to, you can replace expectation of y bar n with capital Y bar n, which becomes E of y bar n square minus y bar n square. Okay, so let us name this as equation number 1. Okay, now variance of y bar n, we got E of y bar n square minus capital Y bar n square. You need to evaluate this value. Okay, you need to find out this value so that you can reach the final statement. So what is expectation of y bar n square is? Okay, so expectation of what is y bar n square? 1 by n. What is the formula for y bar n? Sample mean 1 by n sigma I is equal to 1 to n yi. So I is equal to 1 to n yi square. So this square is for 1 by n as well as for sigma y. You will get 1 by n square expectation of sigma yi whole square. So in the previous theorem also we saw that if sigma x square is different from sigma x whole square, when we came to know that sigma x whole square is nothing but product terms and square terms. Okay, in the previous theorem also we have discussed, we are using the same result. So 1 by n square expectation of sigma yi square plus sigma yi yj. All these are small letters. So before taking expectations, okay, before taking expectations, you should convert these small characteristics y's into capital characteristics. So that also we have discussed that expectation of this can be written as sigma I is equal to 1 to n ai yi square plus sigma. So before taking expectations, you should convert whether it is theorem 1 or theorem 2 or theorem 3. Before taking expectations on small letters, convert them into capital letters by using notation which we have discussed in the beginning of SRSWOR. These small letters will be converted into capital letters by introducing small ai. This small 1 to n becomes capital 1 to capital I is equal to 1 to capital n ai ij. Now you know that ai is a random variable which takes two values 1, 0 with the expectation of ai is equal to n by n and expectation of ai aj is equal to n into n minus 1 by n into n minus 1. So this becomes 1 by n square. Sigma can be taken. Let us take this expectation to first term to the second term. So I is equal to 1 to n. Here ai is the variable, this is a constant. So ai yi square plus here also expectation of ai aj into yi yj. So this 1 by n square is for both the terms. So 1 by n square sigma I is equal to 1 to n. Expectation of ai is n by n into yi square. Now let us take this 1 by n square to the next term also. 1 by n sigma expectation of ai aj is n into n minus 1 n into n minus 1 yi yj. So I'll rewrite that step again. So we have considered this first term of equation number 1. So we got here 1 by n square sigma n by n yi square I is equal to 1 to n 1 by n square n into n minus 1 by n into n minus 1 yi yj. We have summation here. As you can take out this one n by n out of the sigma as it is independent of I. Plus 1 by n square n into n minus 1 by n into n minus 1 sigma yi yj. So n1 n with cancels. You will get 1 by nn sigma yi square plus n minus 1 by n into n minus 1 into sigma yi yj. This is also from 1 to capital A. Let us give this as equation number 2. So what is equation number 1? Variance of y bar n is equal to E of y bar n square minus capital Y bar n square. We have obtained the first part of equation 1. But actually what you need to prove? Variance of y bar n is equal to n minus z by n into s square by n. Whatever the expression is there, or the RHS of the given statement consists of capital N, small n and capital S square. If we observe here, we have the n and n's are okay, but we have capital Yi's. Let us convert these in terms of S square. I think you need to prove this. What you need to prove? This statement you need to prove. Am I right? So whatever proof, it should involve these three terms. So, but it is involving sigma yi square and sigma yi yj. Let us try to evaluate the relation between these capital Y's and S square. So, what is the formula for S square? Population mean square 1 by n minus 1 sigma yi minus y bar n whole square. Okay, this is. Let us expand this. A square plus b square minus 2ab. So this is 1 by n minus 1 sigma. Let us take this sigma try square to each and every term. Let us cross multiply this n minus 1 to the RHS. You get n minus 1 into s square is equal to sigma yi square. As there is no I here, you can write that as n into y bar n square minus, you can take out 2 y bar n into sigma yi. Okay, this is sigma yi square plus n y bar n square minus, what is the formula for capital Y bar n? 1 by n sigma yi. Sigma yi can be replaced with n into y bar n. So 2 into y bar n. So sigma yi square plus n into y bar n square minus 2n y bar n square. So you got this as sigma yi square. You will get minus n into y bar n square. So this is n minus 1 into s square. Okay. We need this term actually in equation 2. You need the expression for sigma yi square in terms of s square and also sigma yi yj in terms of s square. So sigma yi square will be n minus 1 into s square plus n into y bar n square. Let us give this as equation number 2. So to show this one, we have arrived at equation number 1, which is nothing but E of y bar n square minus capital Y bar n square. So you have evaluated E of y bar n square of equation number 1 first part, but this is involving sigma yi square and sigma yij square. In the next step we are trying to write sigma yi square in terms of s square. So by considering this s square, you got sigma yi square is equal to this. So this part is evaluated. Next our focus is on writing sigma yi yj in terms of s square. Let us see how to find out this sigma yi yj in terms of s square. For that you consider y bar n whole square. So this is nothing but 1 by n sigma I is equal to 1 to n yi whole square. Again the same result, 1 by n square sigma yi whole square. Let us cross multiply here, which becomes n square into y bar n square is equal to, again you will get squares terms and product term. You got n square y bar n square is equal to sigma yi square plus sigma yi yj. We need this value to find out the yi yj in equation number 2. Sigma n square y bar n square minus sigma yij square. Just now in equation number 3 we have obtained sigma yi square. What is sigma yi square? From equation number 3, sigma yi square is nothing but n minus 1 into s square plus n into y bar n square. So this is n square y bar n square minus n minus 1 into s square minus n y bar n square. So from these two terms we can take out n y bar n square common. We will get n minus 1 in minus. Okay. Again from these two you can take out n minus 1 common. You will get n y bar n square minus s square. So you have calculated sigma yi yj also. Let us give this as equation number 4. Okay. Now let us put 4, 5 in equation number 2. What is equation number 2? Expectation of y bar n square is equal to 1 by n sigma yi square plus n minus 1 by nn. What is sigma yi square? How much you got? N minus 1 into s square plus n into y bar n square plus n minus 1 by nn into, what is sigma yi yj? Just now we have calculated n minus 1 into this one, n y bar n square minus s square. So these two will get cancels. Okay. Let us rewrite and let us simplify this to get the final expression. So how much you got? N minus 1 into s square plus n y bar n square by nn plus n minus 1 by nn into n y bar n square minus s square. It's a long theorem. Okay. Now if you divide these terms, you will get separately the first one, separately the second one, minus s square into n. So how much you will get here? You have s square term here. You have s square. From this we can take out s square n by n common. You will get n minus 1 minus n minus 1. Plus from these two we can take out n y bar n square. In the denominator we have nn. We will get 1 plus n minus n. Here also this is minus 1 and plus 1. These two will get cancelled. S square by nn into n minus n plus nn cancels, and you will get y bar n square by n into n. So here you got n minus n by nn into s square plus y bar n square. Let us name this as equation number 5. Now this is nothing but expectation of y bar n square. Put this in 5 in equation number 1. What is equation number 1? Variance of y bar n is equal to e of y bar n square minus y bar capital N square. So e of y bar n you got as n minus n by nn into s square minus y bar n square plus y bar n square minus n by nm into s square. This is nothing but variance of y bar n under without replacement. This is what you need to do. Thank you.